In this section of the CCDC training, we will be looking at some of the networking concept and how the IPv4 IP address is assigned to different virtual machines. So here's a thing that we need to understand. There are two ways of assigning IP address to a machine primarily. So one is static network, or you can say static IP address, and another is dynamic. We also call this as a manual way of assigning IP address, and dynamic IP address is basically assigned using a DHCP server. So in case of the VMware infrastructure, the IP address that is assigned to the virtual machines as they are created is a dynamic IP address. So right now I have three virtual machines, one Fedora, one Ubuntu, and one Windows 2012 server machine. And the IP address to this machine is assigned in a dynamic fashion. So when we talk about assigning a static IP address, there are three class of IP address range from which we can select a private network that we want to create for our group of virtual machines. So class A has this particular range from which we can assign the IP addresses, and that means that the VMs can have IP addresses 192.168.1.2 till 254. So we do not assign the first and last IP address. Why is that? The first IP address is the gateway IP address. Last IP address is broadcast. So what does it mean that first IP address is gateway IP address? This means that other networks can use this gateway IP address to communicate with this current IP address. So gateway IP address is usually assigned to some routing machines. And those routing machines basically use this gateway address to translate traffic between two different domains. So consider this as the routing machine, and it will have basically two interfaces. So we can call them as interface 0 and interface 1. And let's say that there are two separate networks that are trying to talk to each other. So this network we say is 192.168.1.0/24 network, and Let me make it a little bit bigger. And there is another network, say 2.0/24. So for this network, this router will act as kind of the gateway. So all other machines like 192.168.2.2 till 2.254 can be the IP addresses of machines within this network. And 192.168.1.0.1 will be the gateway IP address. And all the virtual machines can take IP addresses 192.168.1.2 till 254. And similarly, the virtual machines in this particular IP range can take addresses 192.168.2.2 till 254. And the IP address of the interface, which is gateway for this network, is going to be what? 2.1. Similarly, the gateway IP address here will be 192.168.1.1. And we can use some shapes to connect these networks. So that way, whenever a packet request is sent by this network, this router uses the header of that packet and translates it into a format that can be sent to this other network, which we can say is network 2. So that is the important thing to understand in case of virtual networking. And all these machines which are on this particular network can talk to each other. So let's see how this can be configured in case of Linux systems, in case of Windows systems. So assuming that you have VMware infrastructure, what we need to do is, let's say we create a network and we call it VMnet 0. And all the machines that are present in this network, we add them to this particular private network. So this is already done for Ubuntu machine. So how do I assign a static IP address to this machine? So we go to network configuration settings and we need sudo for this. So the interface to which we are trying to assign the IP address is ENS33. And we are using BI editor to make this change. So if I want this interface to pick up an IP address dynamically, and we have a DHCP server, dynamic host configuration protocol server. What I can do is I can add 2 lines, and this machine will pick up IP address dynamically, and I can comment out any lines that correspond to static assignment of IP address. But our task here is to see how to assign the IP address statically. So notice the difference that, and you can use escape and DD to delete a particular line, and you can use small x to delete a character. So what I am doing here is that I am saying that the IP address needs to be assigned statically. I want this 1.3 to be IP address of this machine. I specify net mask as 255, 255, 255.0. So this last bit means that the bit of the host, basically the hosts can take the IP addresses from range, as I mentioned, 192.168.2.1.2 to 1.254. And these 3 octets are reserved for the network, so we cannot make any changes for this particular IP address range. So these 3 octets will always remain uh, fixed. If we want this to change and we want a broader range of IP addresses, suppose we have a large network, in that case, what we can do is use this. So now you can see that we can assign the IP addresses from range 192.168.1 dot star 2 dot star. So it can be, say, 3.3, 4.3. But let's, for the case of simplicity, consider this. And the gateway address, as I mentioned, is going to be the first IP of this subnetwork. So I make these changes and I use colon WQ. And I run this command for the network changes to take effect. Sometimes the changes are not shown up immediately, so we can bring down the network interface and bring it back up. And you will observe that the INET ADDR is changed to 192.168.1.3. So in case of Fedora, this configuration file is a little bit different. If you want to change it from command line, we need to go to etc sysconfig network scripts ifconfig ens33, and we can populate these values that boot protocol is static and IP address is 1.2, netmask is 255, 255, 255.0, gateway is the first address. This DNS means the name server for this network. If you do not have any name server configured for your network, you can specify the value 8.8.8.8, which is Google's name server IP address. And we can restart the service here as well. If there is no networking service daemon, you can use I need D. So we can use system ETL to start network manager, and the changes will take effect. So, and we also need to make sure that these two machines are on the same network. So this is basically VMnet 0. And now we can see if the machines can talk to each other. So we can send packets from this machine to the Ubuntu machine. And in case of Fedora, we can also enforce this using the network settings if the machine does have a user interface. So you can move this IPv4 from DHCP to manual and specify these values. And it will be manual networking. Let's see what the network configuration is for this Windows machine. So if we see the manage and go to settings and network adapter, we will see that it is currently network address translation, but we want to move this machine to the private network as well. So currently you will notice that the IP address is something that is assigned by our DHCP server. So we change this, and you will see that no network connections. So we will open network and sharing settings. We'll go to adapter settings. And you will see that it is currently obtaining IP address automatically, and we will change it to manual. Let's assign it 1.4. And the command to check IP address is IP config in this case. You will see that it took the IP address 192.168.1.4, and it can communicate with other machines on this similar network. So another thing that for this tutorial I want to mention is that whenever we assign these private IP address range, So the class A has this private range 192.168.1.0. For class, actually this is supposed to be class C. So for class B, it is 192, or rather 172.16. And for class A, it is 10 dot. So this should be 16 and this should be 8. What this value means is that the network has 24 bits and the host has 8 bits which it can play with. And if we see what is 2 raised power 8, it is the number of IP address that it can have. So 255. And in this case, the number of IP addresses we can have is based on the host bits. The host bits are 16 and the network bits are also 16. So this network can have IP address somewhere around something like that. So if we, it will be somewhere in this range because we need to discard the first and last IP address for the network and host bits. And for class A, so we can have up to this many IP addresses. So you would have noticed that class A makes sense when we have a very large enterprise. Class B makes sense for a medium grade enterprise, and sorry, class B, and class C makes more sense for a small network. So hopefully this gives you an idea how to configure the IP address of a network in a static fashion. And thank you.